Hey, what's up everyone? This week I have an exciting topic for you because we are going to use Copilot, GitHub's AI-powered coding assistant, and we are going to use it to refactor some Swift code. And I can tell you I'm pretty excited to see how it's going to go because before recording the video I gave a quick try to Copilot just to make sure it was working as expected, and I'm already very impressed with what I've seen. But before we get started, let me tell you about the sponsor for this video. This video has been sponsored by Realm. If you've never heard of Realm, it's a fast and swifty alternative to either SQLite or Core Data that makes persisting data basically as simple as working with native Swift objects. And here you can see an example of what the code looks like when you're persisting data using Realm. And what's great with Realm is that it also comes with a built-in cloud data synchronization. And as you can see in this short demo, this data synchronization mechanism makes it quite easy to build, for example, a real-time messaging feature. If this has gotten you curious about Realm, you will find in the description a link that will give you access to both tutorials and the code of a sample app. Finally, if you want to give Realm a try, you'll want to know that it comes with a free tier that you can use for learning purposes or to run a small application. And you can get even more free credits by redeeming the code that is in the description. So once again, I have a big thank you to Realm for sponsoring this video. And now let's start using Copilot. I've told you that we're going to use Copilot to refactor an iOS app, and this is what this app looks like. It's the same app I've been using in my previous videos. So remember, we have a first screen that displays a list of movies, and when we click on a movie, we see a detailed view of this movie. For now, the code base behind this app is far from being great, so we are going to try and improve it with the help of Copilot. As you can see, this is the view controller that displays the details of a given movie. And what I want to do first is to extract the conformance to UI table view data source into an extension. And what I'm going to do for it is that I'm going to simply remove the code that implements UI table view data source. So I'm going to remove the conformance and also the methods. Then I'm going to start writing an extension to make movie details view controller conform to UI table view data source. And what's gonna be pretty impressive is that just based on this single line of code, Copilot is going to be able to suggest an implementation that would make movie details view controller conform to UI table view data source. All I need to do is hit the spacebar and you can see the suggestion appearing. So I'm going to validate it so that we can read it. And as you can see, Copilot has been able to infer the code for both table view number of rows in section and table view cell for row at index path. And what is particularly impressive is that the code that it has written makes total sense, because for the number of rows in section, it is indeed the number of elements in my array cast. And for the implementation of cell for row at index path, we can see the very familiar pattern of dequeuing a cell with the correct identifier. Now, it's very possible that this identifier has been inferred by Copilot incorrectly. I might need to fix this, but nonetheless, the general idea is here. We get a cell, we get the correct object by using the index path row to subscript the array, and then we set the properties of the cell. Now, of course, this code is not 100% perfect. For instance, here to set the labels of the cell, it's using the old UI table view cell API. But this is already a great starting point on which we can iterate, and not having to write it ourselves by hand would of course save us a lot of time in the long run. Okay, so now I've removed the code that was written by Copilot and I'm back to the code that was there before. And I want to try something a little bit different. What I want to do is that I want to comment this code right here, which is my conformance to UI table view data source. I'm also going to remove the conformance from the declaration of my class. And now, just like before, I'm going to try and create an extension that would conform my class to UI table view data source. And what's pretty impressive is that this time Copilot has apparently been able to understand that I wanted to take this code that I had commented out and I wanted to move it into its own extension. So I'm going to accept the suggestion, and as you can see, the code that is suggested is exactly the code that was right here. So this time I do find the code I had written for the implementation of table view cell for row at index path, and we can see that, for instance, I am using a different API to configure my cell, and now I just need to remove the code that was commented out, and my refactoring has been successful. I've been able to extract the conformance of movie details view controller to the protocol UI table view data source into its own extension, and I was able to do it with the help of GitHub's Copilot. So that was already pretty exciting. Now let's move on to a second example. And for this second example, I want to refactor refactor my networking code. Here we can see a function getMovies, and it is the function that is called to get the array of movies that the app will display. And we can see that the API of this function is not great because its completion handler takes both a movie response that is optional and an error that is optional. And this pattern is not great, and it would be much better if we were to use the result type instead. So what I do is that I start writing the signature for a new overload of the function getMovies. As you can see, this time I am indeed using the result type instead of two optional arguments. And now let's see what Copilot is going to suggest. And as you can see, this is pretty impressive because Copilot has been able to learn from the implementation of the already existing getMovies function, and it's been able to basically provide a new implementation of the same function, except that this time the new implementation is indeed using the result type, because as you can see, when there has been an error, the completion handler is called with the case failure, and when there has been a success, the completion handler is called with the case success. And so now all I would have to do is to simply get rid of the original implementation of getMovies in order to only keep the refactored version and start using it throughout my codebase. So now let's try to do the same thing for this second network call. We can see that there is a small difference because this network call takes an argument in addition to its completion handler. So let's try and make it work with the result type. So I'm going to copy and paste the signature of the method, and I'm going to use the result type here instead of two optionals. And as we can see, Copilot has once again been successful in suggesting a correct implementation for our new function. And something that's pretty interesting to remark with this example is that since we have specified we want a result that is either a non-optional UI image or an error, and given that the initializer that creates an image from a piece of data can return nil, Copilot has decided right here to force unwrap the image that was decoded. But on the other hand, if we try to remove this code and state that this time we are okay with the result returning an optional UI image, which makes sense because, for instance, UI image view does take an optional UI image. This time, let's see what Copilot will suggest. And as we can see, Copilot has been able to adapt the code it generates because this time it's no longer trying to force unwrap the decoded image. Okay, so for this third example, I'm going to try something a bit more complicated. I want to create a view model for my movie details view controller. And what I'm going to do is that I'm going to basically create my view model, so extract code from my view controller into my view model. And I want to see just how much Copilot is going to be able to help me in the process. So first, I'm going to start by selecting the data that the view controller operates on, so the movie and the cast members. I'm going to move it into the view model. Then, of course, I'm going to create an instance of the view model in my view controller. So it's going to be movie details view model. Then I'm going to start and create the method fetch data, so the method that will be called by the view controller to tell the view model to fetch the data that will then be displayed on the screen. And this is actually quite impressive, but as you can see, based on the pieces of data I have moved from my view controller to my view model, Copilot has actually been able to suggest an implementation for the method fetch data. And as you can see, this implementation is calling get credits in order to get the data to show the credits of the movie, and it's then storing it inside the array that has now been moved inside my view model. And if we try to compare, this code, so right here, is the same code that I have here. Of course, now what I want to do is to get rid of this implementation, try to also declare the poster inside the view model, and see if Copilot is able to move both network calls from the view controller to the view model. So I've added a new property that will store the poster of the movie, which is an optional UI image. And now I'm going to try to again implement the method fetch data. And this is super impressive because Copilot has indeed been able to successfully understand that what I want is to move these two network calls right here from the view controller to the view model. So this is already extremely impressive. Now the next step is to try and remove the code from the view controller and see if Copilot is going to suggest calling the method fetch data on the view model inside viewDidLoad. So I need to get rid of this call right here, of this call right here also. And so now I'm just going to try and add a new line to the method viewDidLoad. And what is really impressive is that indeed Copilot is suggesting that I call fetch data on my view model. And now I'm going to try one last thing for this video. So I've introduced in my project a type called variable, and variable is basically a box inside which we can store a value and a closure that will be called whenever a new value is being set. And it's basically a simple way to implement some kind of data binding between a view model and a view controller. And in the view model, I'm going to update the property poster in order for it to be stored inside a variable. Of course, I also need to update the code to get poster, and more specifically, I need to update the way that I store the poster I get from the network call. So I'm going to select this code and remove it. And what is pretty impressive is that Copilot is indeed able to immediately suggest the correct new line of code, which is to store the poster I get from the network in the value property of my poster property. And now that my view model has been correctly updated, I'm going to go back to my view controller and I'm going to start writing the code to set the onUpdate closure of the variable that holds the poster. So let's get started. I do viewModel.poster.onUpdate. And so once again, as I've been saying throughout the video, this is quite impressive because once again, Copilot has been able to suggest the correct implementation. So we have the implementation where we write a closure that takes as an argument the new poster. That new poster is indeed set on the image property of my poster image view, and we can see that Copilot is even as smart as using a weak self in order not to introduce a retain cycle. So I'm going to stop here, even though I could probably spend hours just trying to see what Copilot is going to suggest. For me, this video was actually my first experience of using Copilot by myself, and I've got to say I am more than impressed with what I have seen. So if you also want to start experimenting with Copilot, I've put a link in the description that explains the steps you will need to follow. But the bottom line is you need to go on GitHub and ask to join the waitlist to get access to Copilot. And once you have access to it, you need to follow a few more steps just to make VS Code work with Swift files. And that's the end for this video. Once again, I have a big thank you to Realm for sponsoring it. If you have any suggestion on how I could be using Copilot in a future video, please let me know in the comments. Thank you for watching the video and see you next time.